In this video, we're going to be looking at the types of reaction. We have displacement reaction or substitution, we have addition reaction, we have elimination, we also have rearrangement. So we're going to begin with the first one, displacement. Now for displacement reaction, or what we call substitution reaction, it is a kind of reaction that an atom or group is replaced by another atom or group. Now when we're talking about the displacement, it is actually the atom or group that is attached to carbon that is being displaced. So it can be hydrogen, it can also be another atom, or it can be group. If it is a electrophilic substitution, in electrophilic substitution, it is often hydrogen that is displaced. An example of that is if we have C6H6 plus HNO3. Now, in the presence of H2SO4, when they react, what you will notice is that we're going to have C6H5NO2 plus water. Now, what happens here is that the NO3, its NO2 will go to remove one hydrogen from this place and attach itself here. Now the H2SO4 doesn't really participate in this reaction. So when we're talking about electrophilic substitution, we're talking about electrophiles, that's electrophilic reagents. They are those reagents that tend to attack substrate at a positive or a position that is highly rich in electron. So they are from the word electrophile. Electro stands for electron, phile stands for lover. So electron lover. So for you to love electron, it means you are positive. So because electron is negative, so for you to love negative, it means you are positive. An example of electrophiles are H plus. We also have H3O plus. We also have even NO2. We also have AlC3, Cl3, and even bromine is also part of it, and also O3 is also part of. These are electrophiles. Apart from that, we also have nucleophiles, because if this displacement happens in a nucleophilic substitution, it is often an atom other than hydrogen that is displaced. Now, what are nucleophiles? Nucleophiles are reagents likely to attack the substrate at a positive or low electron density. So nucleophile, we have already said, means lover. You know, nucleus is positive, so it means for you to attack a positive side, you are always negative. An example of that is, let's say, H2C, or you can also have H3C, that's minus. Even halogens, they are negative. So, you know, the iodine, the chlorine, and all of those ones. And also we have Cn minus. So these are nucleophiles. So an example of the displacement reaction in this is we can have C2H5O, that's an ethanol. If we react it with HCl, we're going to notice that the chlorine will remove the alcohol functional group and replace it. So we're going to have C2H5Cl. We're not going to have water. So that is it. The next one we'll look at is addition reaction. Now, in character, if it is electrophilic, it could be electrophilic, it could be nucleophilic, it could even be a free radical. It is dependent on the type of species that initiates the process. So, if, for example, we have an ethanol or acetaldehyde, and We react it with hydrogen cyanide. Another name for hydrogen cyanide is formonitrile. Formonitrile. So if you retry, what you notice is that the product will be CH3CH. Now the oxygen and the hydrogen will detach from the cyanide, and this is what you are going to get. So nitrile. Now, so one thing we need to understand is that in addition reactions, two molecules combine to form one single molecule. So the two molecules combine to form a single molecule. So addition frequently occurs at a double bond or triple bond, or even at small size rings. So the next one we'll look at is elimination. So when we talk about, and the next one we're going to look at is elimination reaction. When we talk about elimination reaction, we are looking at a reverse of addition. Now, the one that is common everywhere is the loss of hydrogen and another atom or group from adjacent carbon atom to produce alkenes. We have alpha elimination. We also have beta elimination. Alpha elimination is the removal of atoms or groups from the same atom producing a carbene. Now, a carbene is a molecule containing a neutral carbon atom with a valence of 2 and 2 unshared valence electrons. So, elimination, alpha elimination is the removal of atoms or group from the same atom that is producing a carbene. Then for beta elimination, it is the removal of atoms or group from adjacent atoms to form a multiple bond. If the removal is from other different atoms that are not adjacent, it may result to a ring form. So we'll look at an example. So this example is that if we have an ethyl bromide and let's say we remove hydrogen bromide from it, we're going to get a double bond. We're going to get an 18. In the same way as well, if we have an ethanol and we remove water from it, we're still going to get an 18. We'll still get an 18. The last one we'll look at is rearrangement. So in rearrangement, what we will notice here is that bonds in the reactant are scrambled, as in the conversion of a compound to an isomer. Now, we can get this through intermediates that are essentially cations, anions, or even radicals. Now, also, one thing we need to know is that in this case, the one that is very, very most common that we know are those that are involving electron deficient species. An example is that if we have a methyl group bonded to carbon atom, bonded to another methyl group, and a different methyl group. Now, okay, we have double bond here, CH2. Okay, let's make use of this. If you add hydrogen ion to this, you're going to notice that the bond will be broken, and you're going to get something that looks like this. Okay, CH, then So the bond will be broken and you will now get CH3 here, and this carbon atom becomes positively charged. It can also move further. This can be an intermediate. It can also move further and rearrange, and we'll have something like this. And it will move. Here becomes positively charged, and the methyl group can rearrange and come here and stay. It can also move, rearrange again, and we can have something like this. Double bond will form again. And you can get this. Now this reaction here, for it to happen, you will remove hydrogen ion from it. You will get back the double bond that is there. Now this reaction can move both forward and backward. This reaction can move both forward and backward. Remember to subscribe to my channel if you have not. Thank you. You can just subscribe by clicking the subscribe button there.